Please welcome Cheng.
Testing. That's actually a pretty great summary. First class files, all right? But first, before starting today's sponsors, Red Badger, Bloomberg's, and the rest. Red Badger, we owe them a favor for making React Takeoff a few years ago, and I'm very grateful for that. And they promised me also to make Reason Takeoff. Just kidding, they actually never promised that, but it would be a nice thing for them to do, just saying. This is the second part, indeed, of the talk, Taming the Meta Language, which I did at ReactConf 2 weeks ago, barely. Let's start with a small story, all right? A long, long time ago, there was a language. It's a fictional language. It's a simple but primitive language, and in which people wrote programs, and they were rather productive in it. That language was great, except it lacked one thing in retrospect. It lacked a way of quickly repeating statements, let's say. So in order to circumvent that, at first, the programmers were just copy-pasting this around and mastering the editor shortcuts and all, and putting a comment there just in case it gets out of control and everything. And at one point, it gets rough, and they said, you know, that's not a very good way of doing engineering, isn't it, right? Let's make a tool to solve that, right? How do we solve that? So someone came up with the ingenious idea of a pop-up. You know, you will enter a range in that pop-up, and it will generate this piece of code with a pragma that delimits the part that's generated. And even better, when you click on the pragma, the pop-up pops up again, and you can change the number, and the code will refresh accordingly. And it was all wonderful and nice, and to be honest, people were rather productive in it, and they didn't need to learn much more. And so these gang of programmers, they continue making dozen such tools and bundled them together, and all was beautiful until one day they come across this other new programmer writing in a completely different language in a much more primitive looking tool. All right, there was no code generation, nor the dozen bells and whistles of like, you know, whatever prettier way of doing things and all. It's really dirty. And the programmers kind of ask this new program, how can you possibly work in such a primitive environment, right? Look at how productive we are. And they said that until that new programmer showed them this. This is part 2 of the Taming the Meta Language talk, so quick recap. We're talking about taking what's at the meta level, common test documentations, file system, folder, build system, package management, and push them lower so that they can be better communicated with less hassle. Today, I'm going to give a more concrete talk, and it will be lots of examples, and we will talk about this one single feature that Reason or Camel has. Just one feature that illustrates this mentality. And I kind of want to use this feature to demonstrate how we can push down into the language what was previously in the React community, for example, in the meta language level. And just to repeat, Reason and OCaml, I will use these two terms interchangeably in this talk. Reason is a new syntax, but semantically it's the same thing. It's a syntax, a toolchain for OCaml, and we made Reason binding to React.js too, which you can try on these links. Here's a small ladder, like in the last talk. So everybody says, you know, with first-class functions, right, you have data, and then you go one level of function, and somehow people mentally just stop there, and they're like, first-class function, Turing complete, we can do everything, why do we need even more things, right? It's basically over. We solve programming at this point. That's not what's actually happening in everyday engineering, right? It's a matter of granularity. Sometimes you do want a bigger granularity. And you know, after function in the React community is probably a React component, right? And then a stateful React component, and so on and so on. And for better and worse, we're currently using a bigger building block that is the concept of component. But what's after component? You know, we all use it. What's immediately after that? Right? We all use it, but we subconsciously never really considered that as a part of the language until very recently. I'll give you a hint. Right, what is that? Files, folders, build systems, packages, libraries, right? Package installers. And like I said in my last talk, the higher you go, the blurrier it is. Right? What if there's a system that takes some of these concepts that come afterward and then push them back down into the language? And it turns out there is such a feature in Reasonable Camel, and it's called modules. Not enough? Exactly. Let me try one more time. Modules. Modules. Okay, you get the point, right? On my tombstone, this guy really loved modules. We'll be talking about the first 2 points in this concept of modules, and we'll briefly hint at the third point. There are many points left, but we don't have that much time. It's a very deep subject. And every one of these aspects and more tame an aspect of our current meta language. And module is that next level in the ladder that drags the meta language down back to the language. As you can see, these are just normal statements inside a module. You have a type, you have a let binding, you have a function declaration, and module basically just wraps that around. Give it a little nice scope. And it can even wrap other nested modules recursively into a logical unit. That's what I mean when I say granularity, right? And then bundling might remind you of JavaScript objects, right? But it's a little bit more featureful in this language. And you can refer to types and let bindings and all through that modular scope. So it's kind of like a first-class thing you can kind of carry around. So this is basically a normal let binding. Let another person equals to, what type is it? School.profession, the type profession in that namespace. I've been using this Keynote animation feature called Magic Move a lot, and it's dramatically improving my slides. I really like it. You should try it. So that was the mundane part of module. There's really not much to know beside that. Okay? Now here's the interesting part. See that commented line there? Module actual component include base component. This is kind of like a JavaScript object spread, except typed, and it spreads not just a little bit of keys and everything like that. It also spreads types, let bindings, function declarations, and even other nested modules. So it basically takes, in this case, what's in base component, these two let bindings, and just spread them into the actual component, and then actual component happens to override that let binding to the greeting binding. And the cherry on top, that include is completely compiled away. So at the left-hand side, it's previous slide's example. The right-hand side is actually the compiled output from a compiler called BuckleScript, which compiles OCaml to JavaScript. And the compilation output is pretty clean. And you can see that there is actually no runtime cost there. You can do as much as what it used to be meta-programming in just programming paradigms. And so throughout this talk, since the theme is pushing things down, I'll come back to this question again and again. And this time I'll ask, what do we push down, actually, right? We push down a disciplined version of mixins from the meta language into the language. In that context, module includes are like mixins or some form of inheritance or whatever. And if you look at that piece of code here, it kind of looks like the deprecated React mixin facility. And very important difference is that this has none of the downsides of what we deprecated inside React, the mixing facility. There's no library-specific API to learn. There's no unpredictable mixing behavior like overriding properties or like chaining functions together. There's no perf penalty during initialization time, thanks to the design of the language and its type systems. We expressed enough of our intent writing the code itself that the compiler can just do the dirty work for us. That's the whole point of software, isn't it? And does anyone remember why higher order component was created? Anybody was there? Higher order component was a proposal that got submitted because part of the reason for existence was to deprecate the React proprietary mixing system. But since we have this language level better mixing system without any of the downside of the previous mixing system, we can wait a little bit more before reaching for higher order component. That is not to say we don't need higher order components anymore. It just means that higher order component, when you use them, they're going to be that much more significant and valuable. This is very important. And the next time when a newcomer comes and look at the code base, they don't have to learn any proprietary library-specific concept. If they know module, if they work in a different code base, they know exactly what these agnostic components do, right? They're not tied to React, really. They're just two object-ish kind of thing. And here's the kicker. Every file is a module. Remember this earlier example? This is just a bunch of things you will write normally in a file, right? And remember how we showed as an example that you can wrap that in a module? That's how an OCaml build system actually works. It basically takes a file, without indentation, without the module wrapping and everything, and implicitly wrap it with a module so that you don't have to write that module wrapper. The build system does it for you out of convenience, right? And here you see another file called agenda.re that refers to the other module, the other file, the first class file that is that file, school.person, right? And in light of that, a nested module, in this case, when you have this school.re file, there's a nested module GPA here. What is that? A nested module, since module maps to files, since files map to module conceptually and semantically, a nested module is actually a nested file, okay? First class files, a file inside a file. And of course, a file with nothing but nested module, what is that? It's basically a folder. Let that sink in a little bit. So it's not just an interesting metaphor, it's really semantically valid. This does map this way in the type system. And there's no notion of file once you're after the build system. Now, here's a contrived example just to drive the point home. You have A.re and B.re. A.re has these statements, and B.re just include into that implicit module that is created at compile time, at build time. And this is basically the equivalent of a file copy operation, but expressed through a language. And remember, there's no runtime cost, so this is actually a file copy under the hood. You can open up the JavaScript and look for it yourself. Now, again, what did we push down? Code generation. And another category, a whole category of meta programming suddenly just gone. Right? Even in JavaScript, where the community is very proud of our first-class function and everything, and we say we basically, first-class function, that's all we need, we still do code generation sometimes. What does that mean? That means like the granularity of function wasn't enough, right? We still sometimes use code generation and boilerplate generation in JavaScript, and module basically deprecates that need to a certain extent. All right, now here's the second concept. It's also a very straightforward concept. A module's type, since this is in a type language, is called a signature. So I'll refer to these two interchangeably. Here's a normal module. Like the previous example, I just fill out some implementation detail and all. Okay? And you see two types that are alias. Type person is just alias, a string, they're equivalent. Type people is just a list of person. Okay? You have a simple naive list as your database implementation detail. You have an add person here, which is a function that adds a new person to that database. And then you have a sort people alphabetically as an implementation detail. Now, my question to you is, what is the type of that module? OCaml's types are mostly inferred, so it gives you a type for free. What is that? When you click on your editor and hover over that module, what does it show you, right, as a type hint? Right. That is the type of the module below, right? Kind of intuitive, right? It just generates a type for you. Or you can, if you want, you can actually explicitly type it out yourself. This is not too complicated, but do you see how immediately useful this is? How powerful this is, but how concretely, immediately useful this also can be. Since a module, a foo module maps to a normal file, foo.re, what does a module type maps to? A module type maps to an interface file, okay? It's kind of like a flow TypeScript definition file in that sense, but a first-class one that you can carry around and use and modify. So what did we push down this time? Formalized version of the documentation. Now we have that, right? Documentation. Who has never seen a code base without proper documentation? Right. The reality of software is that we don't bother really with that because it's so blurry sometimes. We've got to drag this down so that documentation becomes an easier step. And in OCaml, the community thought that that modules and interface signatures are such a valuable idea that they decided to basically wrap these type signatures with special comments, special directives, and generate the corresponding HTML documentation for it for convenience reading, right? And every time you browse some OCaml documentation, like here, the standard library list, there's an interface file and a normal implementation file of the same name in the OCaml repository, list.ml, list.mli. These comments, don't get these wrong. These comments actually type check. So when you use that special notation here, for example, for cons, and you say this you refer to another function and you refer to another module, these actually type check. So if you generate a documentation and your comment is stale, the system actually tells you. And in case you don't believe me, how much of this documentation meta language can be of a churn, this is a library I wrote called React Motion. And this is React Motion's documentation page, a chunk of it, to show you how much of this this is fuzzy in a language like the language we use currently. I basically, I'm going to highlight all the snippets here that can basically be reduced just to language level concepts. Right? And I'm being very generous here. These things, if you read through the sentences, they're really just a type, but I write them out because we don't have this formalized systems and all. And I want this to be newcomer friendly because they don't know the notion of type sometimes when they come into the JavaScript community. But now when newcomers want to contribute to a feature, I ask them, and when they come in and I ask them, okay, you changed this feature, can you also update the documentation at the same time? They have to read through the documentation, rephrase some sentences, recorrect all the bullet points and everything, and this is very lossy. This is a very lossy process. And most importantly, this is not resilient at all to change. Right? Process very lossy. Think of your workflow. Think of, you code, you write some tests, you iterate, you write a README, maybe, maybe not. An interface file, basically, and the one that you get for free, basically gives you a higher basic quality bar in the community. You might still not want to write comment around the interface files. You might still not want to generate the HTML documents, but you realize at this point how little we're asking of you. And of course, there is more. Remember this example before? If you don't want to expose a certain method, just remove it in its interface. You can still have it in the implementation detail in the actual module, but if you remove it, if you hide it in the module type, what happens is that the type system will guarantee you that every module with this type, school type signature, okay, you can take that signature and then plug it into random school modules. Every module of school type can have its sort people, whatever implementation hidden or not have it at all. And it's guaranteed by the compiler that no other place beside inside the module itself can you access the sort people alphabetically method. And since a module type maps to an interface file, like I said, you get the constraint that your library's public API is just the interface file at the top level while you remove a few statements from it, right? This is what it is, a public API. It's all the implementation detail minus a few. And here's an actual last trick, let's say. There was a very wise programmer, anonymous programmer, who told me one day, lots of languages have facilities for encapsulating things. Okay? Most of them, you can just come up with the concept of encapsulation, but they don't really have a facility for abstracting over things. What does that even mean, right? Back then, it wasn't really clear to me until I worked with this language. And I would like to illustrate this with the previous example. So this is code. This is just a normal module signature, no implementation, just kind of like an interface file. This is encapsulation, okay? And this is abstraction. You declare in that module signature, there is the type person and there is the type people. You are not even exposing the fact that people is actually just alias for this person. You don't even know this relationship. But I expose this fact. I expose the existence of these two types while hiding away what the types are under the hood, right? But you see, even if I hide away my implementation detail, it doesn't prevent me, even if I abstract away all the things, it doesn't prevent me to establish relationship between values. And to use a graph, instead of coding against someone's API that's simply encapsulated, which is round, right? It's kind of like you're just reaching in and getting a few methods and assuming the rest of the world is kind of round. You're basically coding against a more defined shape. You said, well, this is still implementation detail, but at least you give me the skeleton of what I'm asking for. And now, once again, what did we push down? These thoughts are the kind of thoughts that we don't even know how to express in code before in a dynamic language. We always carry around that in our head. And these patterns that we learn over the years, that we accumulate, a newcomer comes into our code base. I onboard some newcomer into our code base too, and they just plain don't understand it, and then you realize you climb really high and you remove the ladder for the other people. And ultimately, it's my dream one day that maybe if someone asks me to write an application, I'll just go and write nothing but application-specific code. Because right now, that's not the case in our code base at all. Right now, in our code base, a third of our code or a quarter of our code is basically these kind of boilerplate patterns that the language didn't really absorb. We basically come up with these patterns, and you open it and you realize, well, this is basically, okay, it's trying to do that thing particularly. But a third of our code base is that, right? Maybe one day we can have this separation where I just write code and it's application specific, and whatever else is abstract away in the language. That will be a very ideal language one day. And the second thing, right? Does anybody know of this running joke? There's a thing called react.__ secret DOM do not use or you will be fired. Okay, and people kind of turn that into a parody inside Facebook, and they have like foo.__ secret do not use or you will be fired, another module. And then it's funny because you search across the code base to see how many instances of that is actually in active usage. You realize there's a whole list, right? That's meta language for you. You didn't bake into the code. Someone really wants to get fired, but they still want to use that feature. And the point of abstraction, of establishing these relationships that now we've pushed down into code, is that when there is a breaking change in our library, if the library is nice, if the library has lots of backing, they will give us, at best, a migration path, right? And even if better, sometimes they give us code mod and everything. But even then, inside the migration path, inside this blog post and news and whatever, the nuances of the relationship between values and types, the nuances of these changes are kind of completely lost, right? Unless you're really good at documenting this, but that's not the case for everyone. And it's kind of funny in that sense, and kind of ironic that in JavaScript we now insist on immutability. We insist so much on immutability at the code level, but once you zoom out and you check the meta level, you realize when we upgrade libraries, we just silently and mutatively assume that everything still works. What's the point of having this little local optimization of immutable data structure when you upgrade a library and things are broken and you ship it anyways because you didn't care? Types kind of prevent that from happening. It kind of tells you there is a change, and now you kind of immutably, in that sense, upgrade your library to another version, and everybody goes like that. And so much of what we do sometimes that we kind of glorify and call code exploration. This is a trendy one to say. Types, they prevent me from exploring code. So much of what we do that's code exploration and trying things out and see if it works. At runtime, it's really just us fumbling in the dark, trying to figure out what the other side's intent is. There was no exploration in the first place. The other side had an intent. It was a very specific intent. They just didn't communicate it to us. That's not exploration. The other side exposed a very real set of functionality and constraints. Now, the third point. I'm not going to go over this too much because this is kind of like the proverbial marshmallow in that sense. The Stanford marshmallow experiment. Once you see everything as a functor, you kind of want functor everywhere, and then you make your code so hard to read for newcomers, but it's so great for you. It's but a functor, what it is in essence, is basically a function that takes in a module as a parameter, modifies it a little bit, and return a fresh new module without much cost. Right? And since modules map to files, it's like if you took in a file, modify the file a little bit in pseudo runtime, and then output a file at compile time. So you might be asking, where are we going with this? Right? This is nearing the end of the talk, and I hope I gave you just a glimpse of a single feature in OCaml and Reason that kind of I hope makes you see that the language is actually very well designed. And there are tons of other features like this. Extensible records, for example, polymorphic variants, another talk. And even module, this is not over yet. We have first-class module that you can put in a list and just generates. We have modular implicit in the future. We have 1ML, basically unites everything in modules. Record is a module, tuple is a module, function is a module. Everything is just a moded use of module. And if you ask me the full extent, I will tell you I have no idea. All right? But this is an important realization. And I don't know if you have noticed yet that in the React community, people tend to, just like in normal software, go into different directions, explore a little bit the possibilities, sometimes get blocked, sometimes get relatively successful and all. And lots of time they come back with the same answer. Right? It's kind of like in primary school where the teacher tells you there are more than one way to solve a problem. And somehow with 2 ways, you have no idea what you're doing. Now you're truly exploring, and at the end, you arrive at the same good answer. For example, in our React community, the answer has been immutability. Unidirectional data flow. This is very easy to reason about. Idempotency, referential transparency, for example. It's kind of like that when you're also exploring a type language, where you truly go and explore another feature with the types guiding you so that you don't feel like you're actually fumbling in the dark. And if you want an example of that, again, lots of people have heard this before. The first version of React was prototyped in SML, which is a cousin of OCaml, by Jordan, a type language. So yes, exploration is definitely possible, and it kind of enables you, gives you this new way of thinking about things that gives these kind of like paradigm-breaking changes. And that was the second part of taming the meta language. We will be waiting for you in our Discord room. Thanks. I think there are time left to take questions, right? Is that a thing? OK. Let's see. What motivated you to create Reason? What problem does it solve? Well, I just made 2 talks on it. Hopefully, that was clear. OK. But if you want to go and come to the Discord room, we can give you even more technical details. Oh, there's a screen down there. What is the limiting factor for wider adoption of Reason at Facebook and in general? Oh my gosh. OK, so this is actually my next talk. I feel like I'm a salesman in that sense where I just plug my next talk, but this is actually my next talk at React Europe. I will be talking about how to bridging 2 worlds. Ideas are easy. Bridging ideas, extremely hard, but extremely worthwhile. So stay tuned. Avoiding the question here. OK, well, next one. How does Reason's module system improve on the one many language commonly used today? I'm not sure which language you're talking about. I kind of just did a talk on it. Like, sorry, I'm really bad at answering these questions. Well, first of all, if you compare it with the JavaScript module, the Reason module is typed, and it's efficient, right? This is very important. And like I said, there are other things that the module kind of brings into itself. Like, for example, first class module. In JavaScript, it will require some kind of code generation or bundling. I mean, the nuances, you've heard me talk about this enough. OK, next. How does Reason's module relate to, well, this is what I just answered. You know what? OK. So here, I have 5 minutes left. I want to talk about something that's very close to my heart. No, this is seriously important. One of my all-time heroes is Brad Victor, and I think it's also the all-time hero of many of people here. He kind of really changed my way of viewing what programming is and shattered my vision of things and showed me a new world, basically. And throughout these years, and actually Brad Victor's first talk was in Montreal, my city. And throughout these years, I've seen crazy demos inspired by Brad Victor. Like really good demos. Some people, they code in JavaScript, they pull in some libraries and make Brad Victor's demo kind of actually concrete and somewhat usable. And this is very admirable. But times and times again, what I see is that these people, they get inspired, they go into different directions, they explore them, and including me, I've exploring these directions too. I've written my small library on this. And somehow I just never get to use them in production. Somehow it stays as this kind of toy I use on Saturday night. You know, I never, and I'm kind of grown cynical in that sense that I will never be able to use some of these ideas at work. And this has been a very depressing thought for me over the last few years. That we have all these nice ideas out there, but why are they so out of reach if they are so great, if they're so revolutionary? And so my mission statement for myself personally has changed over the last few years in that regard. Instead of going in this different path and create a really polished tool for this and showing other people and feeling proud and explore these concepts for myself, I said, my job is to drag lots of these back into the language. This is really my mission statement. Drag it back into the language so that the next time when someone explores these kind of things, they don't have to write up 1,000, 10,000 lines of code to show the worth of this. They can just write 1,000 lines of code And maybe React one day will just be 1,000 lines of code. Maybe Brad Victor's concept of drawing dynamic visualization and all will only be 500 lines. And then it will be realistic for us to use that in production because everybody shares the same code, everybody shares the same language now. So yeah, small rambling, I guess. This is just very close to my heart. I really want to see it happen, but I realized that my purest way of the past of making this happen hasn't worked out. And this is why I'm choosing this approach of dragging things back to the language so that we can have a solid foundation so that when the libraries get blown away, we don't forget the lessons and relearn all over again. One last question. If you hide module API by commenting out code, does that force you to write all your module types by hand? So you can see that the modules types is actually inferred. The compiler has an option to auto-generate a signature for you. So you generate it once and you remove the one statement manually by hand. I think I'm going to stop answering questions at this point. All right. Thanks a lot, and I'll see you in the Discord room.